State Center, Tripura State Center IE Institution of Engineers, and Professor of NIT Agartala. I am very, very thankful to him for immediately accepting him to give a lecture on EV technology. Since EV technology is most promising technology in our country, and lot of courses is organized by different agencies, a certificate program, diploma program, degree program also. And also we must understand that another 20 years we have great chance and opportunity in EV technology. So now we have invited a great professor and his eminent professors in the field of EV, belongs to electrical engineering, and very much thankful on behalf of the Institution of Engineers, students and the fellow engineers, thankful for coming on board through online. And he has passed UG in electrical engineering. Presently it is called as NIT Agartala, earlier it is TE College, and postgraduate and PhD from Jadpur University. Now he is working as assistant professor and former head of electrical engineering and NIT also. And he is a member in various professional bodies. And ultimately, I want to highlight that he has received Fast Track Young Scientist Award of DST, Government of India, and recipient of Pandit Madan Mohan Malviya Memorial Prize 2019 by IEI, the best paper published in electrical engineering. With this background, I am very happy to invite Dr. Subhadeep Bhattacharjee for giving lecture on EV technology. Thank you very much, sir. Now the platform is yours. Thank you.
Thank you, sir.
Thank you. Thank you very much.
Okay. So I will make a full screen. So at the outset, am I audible, sir?
Yes, sir. Audible.
Audible.
Okay. So at the outset, I would like to express my sincere thanks to Dr. B. Karthikeyan, Chairman of the Tamil Nadu State Center of the Institution of Engineers, India, Engineer D. Gokul, Honorary Secretary of the Institution of Engineers, India, Tamil Nadu State Center, other state committee members and distinguished corporate members of the Institution of Engineers, India, and participants. So as Karthikeyan sir has told regarding the electric vehicle technology, so we all know that EV is a very burning topic nowadays in view of the emission related issues. And first of all, I could not update my slides due to my paucity of time. Anyway, I would like to discuss something regarding the electric vehicle technology in view of actually environmental issues and climate change issues. So first of all, I would like to mention that our energy and power, that is the energy conversion systems, is divided into two categories. One is the electric utility system, another is the transport system. So why these two energy conversion systems I have taken into consideration? The reason behind is that presently our electric utility system, that is our traditional power system, is shifting towards the renewable energy. Presently our installed capacity is around 400 gigawatt, considering the both fossil and non-fossil fuels. And out of this 400 gigawatt, 200 gigawatt is coming from almost 50% is coming from the fossil fuels, that is the coal, oil and gas. And second is the transport sector. Now transport sector, as per the 2019 statistics, 295.8 million vehicles are there on the road. And if we consider the per vehicle average horsepower or shaft power capacity is 100, that is equivalent to 75 kilowatt, then the total transport system power capacity is coming at the tune of 2000 gigawatt. That is 10 times greater than the electric utility system power capacity. So this, and in our 21st century, these two energy conversion systems are going to converge. It is because this electric utility system, as I have told, is shifting towards the renewable energy, that is solar energy, wind energy, all these things. And these are the stochastic in nature. That is, we do not have any control over the fuel input and the power output. That is why to steady power output, steady power yield from the system, we require some storage, require some battery. At the same time, transport system is shifting towards the electric vehicle because pollution amount is less in electric vehicle category, and electric vehicle includes a large traction battery. Now those traction battery can effectively used as a storage for this renewable power. So in coming days, there will be the convergence between these two energy conversion systems. And presently, our road electric vehicles are classified into three types: two-wheelers, three-wheelers, car and electric buses. And till now, the petroleum, that is the oil, is the main source of the fuel for our vehicles. But there are a lot of problems associated with this fossil fuel powered vehicles. We know that our fossil fuel reserves are limited. Coal, oil, gas, these are the finite, and millions of years are required for formation of these fossil fuels, but the depletion rates are 100,000 times faster than they are being formed. As far as the oil is concerned, if we consider the rate of production rate in 2015, our oil will last another 50 years. Gas will last 52 years around, and coal maybe 114 years, like that. Meanwhile, if we can explore more reserves, then the scenario may slightly change. But eventually, these resources are going to diminish completely. So it is another statistics or trend from which we can understand the gravity of the situation. If we consider the present growth rate of oil production, that is 4.7%, the oil will last up to 2033. And if we consider the remaining recoverable reserves of 5%, it may last up to 2052. So in coming days, there will be no oil, and our transport system will be at stake. Another thing is that due to this reason, this IC engine vehicles are mainly run through the diesel or petrol. And petrol, we call it petrol in Indian continent, but in European nation it is known as the gasoline. So as the scarcity is going to increase, so it is going to more expensive in coming days. Another issue is that our oil, gas, coal, these fossil fuel reserves are not evenly distributed on Earth's surface. These are distributed, uh, if we consider the Middle East, from the graph, it is evident that oil is there, but coal is not there. And Middle East is one of the most potential area, most significant area for exporting the oil in different parts of the globe. So similarly, North America, Europe, FSU means the former Soviet Union, Asia Pacific, South America, Africa. So oil, gas, coal reserves are shown. And also it is categorized as conventional oil and unconventional oil. Conventional oil means the oil which are explored through conventional techniques, traditional drilling techniques are adopted for extracting the oil, then it is known as the conventional oil. If some unconventional techniques are used, if the scarcity is more, then some unconventional techniques are also used by the oil company for exploiting the oil. So those oils are known as the unconventional oil. But the thing is that due to this uneven distribution of the fossil fuel resource and oil, particularly for transport sector, the vessels are used for taking the oil from one country to another country, and oil spills are taking place in ocean. It is a very recurring phenomena, and many accidents have also taken place in earlier. And this reason, the effect of this oil spill is also very important, because oil spreads over the water, and oil percolates, penetrates through the porous soil and mix with the groundwater and contaminate. So these issues are there, and in this graph, this oil, gas, and coal resources by region is shown. Unit is given in terms of billion barrel oil equivalent. So this is the unit of energy, particularly the primary energy barrel oil equivalent. 1 barrel is equal to 159 liter approximately. And if 1 barrel oil is burned, the amount of energy released is represented by barrel oil equivalent. So two major oil spills I can refer. One is the Port Arthur oil spill that had happened in 2010, and another is the most devastating accident that had happened in Alaska in 1989, and it is considered one of the most severe human-caused environmental disasters and impacted the environment and particularly the sea ecology a lot. So these are some problems associated with the oil, and mainly our transport sector, they use the IC engine, and in engine combustion takes place. If combustion is ideal, there will not be any emission, but combustion is not ideal. Combustion does not become completely ideal. It is not possible. So always there are some emissions from the IC engines, and the emitted products are the carbon monoxide, nitrogen oxides, VOCs, that is the volatile organic compounds, carbon dioxide, particulates, lead, sulfur dioxide, and many other carcinogenous elements like formaldehyde, acetaldehyde, benzene. So emission is a major reason, and we know that the carbon dioxide is the most important element for global warming. Carbon monoxide is also a toxic gas. Nitrogen oxides are also is a health hazard, and it produces the ozone, and also nitrogen oxides creates the smog in big cities. So a lot of pollutions are taking place from this transport sector presently due to the combustion of the IC engine vehicles. So this is the picture of Delhi smog. Smog means we know that it is the smoke plus fog, some hazy condition, and the nitrogen oxide is the main reason behind this smoke. Also unburned hydrocarbons is there, which is the source of the urban ozone. Now, here I think some students are also there, so we are very much susceptible about the ozone. We know that ozone layer protects us from the ultraviolet radiation. Then why this ozone we are concerned due to these vehicle emissions? Actually, the ozone which we know that is available in stratosphere, it protects us from the ultraviolet radiation. Any rupture in ozone layer, ultraviolet radiation will penetrate, and it will have adverse effect on us. Another ozone is formed due to chemical reaction of nitrogen oxides and volatile organic compounds in presence of sunlight, and it produces ozone. That ozone is the ground ozone, and it is a health hazard. And this nitrogen oxides, volatile organic compounds, these are produced due to this vehicle emissions. And nitrogen oxides, as I have told, is also a health hazard and creates a lot of respiratory problems, asthma, etc. And also this ozone produced due to the reaction of the nitrogen oxides and volatile organic compounds is also detrimental for the green vegetation. So number of popular alternatives of liquid fuels are available, like methanol. Methanol, though it's a toxic one, methanol is produced, can be produced from coal, oil, gas, and biomass. Besides, propane is there. Propane is known as LPG, popularly liquefied petroleum gas. Besides, ethanol is there. Ethanol is produced from biomass through fermentation with the help of the yeast bacteria. Ethanol is produced. It is a non-toxic fuel. Methane is implied by the natural gas, and natural gas can also be used as a fuel in the vehicle as a CNG or LNG, compressed natural gas or liquefied natural gas. Electricity is also used as in a vehicle. Electric vehicle, we use the electricity as a fuel, and it is not a new concept. In 1891, first electric vehicle was invented by William Morrison. Thereafter, hybrid electricity is there, biodiesel is there from Jatropha, and many other vegetable are there from where the vegetable oil can be extracted, and this can be blended with the diesel to replace the diesel amount. So biodiesels are also used in transport sector. In Indian Railway also biodiesel is used. In Shatabdi Express and many other locomotives are run using the biodiesel. Hydrogen fuel cell is also used for driving the vehicle. In space shuttle, fuel cell is a power supply for the space shuttle, and fuel cell is run due to the hydrogen and oxygen. Hydrogen and oxygen are the two important input to the fuel cell. So fuel cell powered vehicles, electric vehicles are also there, not available abundant, but this concept is also there. So it is the basic structure of the vehicle. The first one is the conventional vehicle. It is a simplified diagram to understand the things, particularly for the students. Uh, in uh, in our conventional vehicle system, there is an engine. So this engine actually provides the mechanical power, and this mechanical power is transmitted to the wheel through transmission system. And engine is powered by the fuel. Fuel means our liquid fuel, petrol, gasoline. Okay, and there is another concept is there hybrid. So fuel, engine and transmission will be there. Moreover, another system is integrated motor, and motor also we know that produces electrical energy into mechanical energy. So that mechanical energy is also helpful for driving the wheel through transmission system. So both engine and motor both will provide the mechanical power for driving the uh, wheels through transmission system, and motor is powered by the battery. And now this battery can be energized through regenerative braking. So when we brake apply, some of the kinetic energy is wasted in the form of heat. So if it is possible to extract some of the kinetic energy, and that kinetic energy can be used through a generator, and again some electricity can be produced, and that electricity can be useful for charging the battery. So regenerative braking concept is there for charging the battery. Now this is the hybrid electric vehicle concept is shown over here. But our nowadays Indian government policy and across the globe, the policies are evolved with the plug-in hybrid electric vehicle. So there is a subtle difference between the hybrid electric vehicle and plug-in hybrid electric vehicle. In hybrid electric vehicle, this is shown over here, there is no external power socket for charging the battery. So battery is not charged through the grid power. Battery is charged with the help of the engine or through the regenerative braking. If the external power socket is there and onboard charger is there for charging the battery, then it would be known as the plug-in hybrid electric vehicle. Similarly, this is the totally electric vehicle. If the plug-in facility is there, then it would be known as the plug-in electric vehicle. So in battery electric vehicle, there is no fuel, engine, all these things. The complete mechanical power is produced by the motor, and motor is run by the traction battery. So this is the concept of different types of vehicle, conventional, hybrid and electric battery-based vehicle. This is a general classification. Electric vehicle, as I have mentioned, it is classified into two types. One is the plug-in electric vehicle, hybrid electric vehicle, and fuel cell electric vehicle. Now, this plug-in electric vehicle is classified as battery electric vehicle and plug-in hybrid electric vehicle. As I have mentioned, this is the most important segment presently because the policies are mainly focused with this one. So this is the basic components of our gasoline vehicle or conventional IC engine vehicle. So IC engine vehicles, if it is run with the petrol, then it is spark ignited, and if it is diesel, then it is CI, compression ignition type of engine. So our vehicles, the gasoline vehicles are spark ignited. So these are the different components, different parts. That is the first one is the fuel filler. So it is a nozzle through which the fuel is added into the fuel tank. In fuel tank, petrol or liquid fuel is stored. There is a fuel pump. The purpose of the fuel pump is to pumping the liquid fuel to the fuel injection system through this fuel line. So fuel line is basically a piping system through which the fuel is pumped to the fuel injection system. Thereafter, exhaust system is there. Exhaust systems will driven out the emissions through the tailpipe. Transmission is there. The purpose of the transmission is to transfer the mechanical power produced by the engine to the wheel. battery is there. This battery is known as the auxiliary battery. At the beginning, the engine is started with the help of the battery, and the different accessories are supplied the power through this battery. Is fuel injection system inject the fuel to the internal combustion engine. There is a combustor where the fuel mixes with the air, and this air fuel mix is ignited through a spark plug. So that is known as the spark ignited system. Apart from that, electronic control module is there, which controls the performance of the engine, control the exhaust, and other control of the gasoline vehicle. In hybrid electric vehicle, all these previous components will be there for engine. Besides, as it is hybrid electric vehicle, so electric motor, traction battery, and relevant other components are added in addition to the gasoline vehicles other components. So fuel tank and all these things are there. Beside, there is a traction battery pack. So this traction battery pack provides the power to the motor, and traction motor is there. This electric traction motor converts the electrical power into mechanical power. Thereafter, transmission is there for transmitting this mechanical power to the wheel. Battery is there like previous one. There is a thermal system for cooling purpose. So thermal system actually maintain the temperature of the engine, temperature of the motor, and temperature of different power electronics components. One DC to DC converter is there. The purpose of the DC to DC converter is to convert the higher voltage DC power of the traction battery into lower voltage DC power, which is suitable for different components. There is a exhaust system, internal combustion engine, that I have already told. So it is a hybrid electric vehicle, but this is not the plug-in hybrid electric vehicle, because there is no onboard charger and external power socket for charging the traction battery. Here the battery is charged through the regenerative braking. So that is why one electric generator is shown. Sometimes the motor generator set is used for regenerative braking purpose. This one is the plug-in hybrid electric vehicle. Apart from all the previous components, this one is added, that is the onboard charger and charge port. Through charge port, charging is taking place. There is a onboard charger. The purpose of the onboard charger is to convert the AC power taken from the charge port to convert it into DC power for charging the traction battery. And also the onboard charger purpose is to maintain the voltage, current, and other performance of the traction battery, and to prevent it from overcharging, discharging completely. Other components are already there. Power electronic controller is there. The purpose of the power electronic controller is to control the torque, speed of the motor, and also power electronic controller controls the energy flow from the traction battery to different components of the electric vehicle. All electric vehicle, it is more simplified because this fuel and engine system is not there, but remaining all other components are present, like traction battery pack, charge port, transmission, onboard charger, battery, thermal system, DC to DC converter, power electronics controller, electric traction motor, etc. This is the hydrogen fuel cell vehicle. There is a fuel tank, but this fuel tank is for the fueling the hydrogen. Hydrogen acts as a fuel, so hydrogen can be filled up through the fuel filler. There is a battery pack. Battery pack is energized by the fuel cell. So initially, the auxiliary battery is used for starting purpose before the engagement of the traction battery. DC to DC converter is there. Fuel cell stack is there. Because a single fuel cell produces a very nominal voltage, so fuel cells are connected in series, and these series connected fuel cells is known as the fuel cell stack. Electric traction motor is there, thermal system for cooling purpose. So all these things are there, but the thing is that the motor is powered through the fuel cell. It is another conceptual issues towards the popularization of the electric vehicle. The thing is that our oil, that is the liquid fuel, has two routes for its utilization. As I have mentioned in my first slide, there are two energy conversion system. One is the power, another is the transport. So that oil can be utilized in power electric utility for production of the power. Therefore, that power can be transmitted to the uh, public charging station. In public charging station, electric vehicle can be charged. Another way is the fuel, that liquid fuel or oil can be sent to the petroleum refinery. After refinery, it can be transported to the fuel pumping station. Thereafter, our IC engine vehicle can be pumped. But there are some problems associated with this one. It is found more efficient, this technology route. So from this picture, we can identify something. So if we consider our plug to wheel efficiency, plug to wheel efficiency means taking the power from the public charging station up to wheel. The efficiency is found in the tune of the 76%. Actually, this is calculated like that approximately. Battery efficiency 90%, onboard charger efficiency 95%, and other power electronics converters efficiencies are 95%. So in this way, overall efficiency is found to be 0.76 or 76%. And if we consider the total generation, transmission, and all the system efficiency, so overall efficiency is coming around 23%. Another way is the refining of the petroleum, thereafter transmission of the petrol through transportation vehicle to the fuel pumping station. Here, the pump to wheel efficiency is found less in comparison to plug to wheel efficiency. Plug to wheel efficiency is found higher due to the incorporation of the different power electronics devices, which efficiencies are high. But pump to wheel efficiency is what is, there are some losses. Mostly the losses are taking place in engine losses, which is engines are operated or engines are functioned on auto cycle. In auto cycle, there are almost 72% losses are there as auto cycle losses. Thereafter, some losses are there due to standby, which is known as the standby losses. 2% losses we can consider for transmission of the power. So that is 100% is the fuel, then 100 minus 72 minus 10 minus 2. So it is coming around the 16% efficiency, pump to wheel efficiency. But here the plug to wheel efficiency is very high, 76%. So that is why the overall efficiency in entire process for electric vehicle charging is 23%, while it is 13% for normal IC engine vehicle. And the efficiency of a engine and efficiency of turbine, which is used in electric power plant, are almost same, around 30%. But as I have told that our engines are run with the auto cycle, it means that there is no provision for energy recovery. We cannot recover the heat. So after combustion, the heat is released to the radiator or tailpipe. We cannot recover that heat. So this is the major loss. This loss is the around 72%. But in turbine system, what happened? We have the possibility of recovering the heat after turbine, after combustion, and that heat can be utilized for production of the steam. And again, that steam can be utilized for running the steam turbine. So the overall efficiency can be improved. So it is known as the combined cycle. So power plants are run through combined cycle, while this automotive IC engines are basically run on the auto cycle. So these are some of the reason behind the poor efficiency in this type of process. So it is the vehicle to grid concept, because it is found evident that the most of the time our privately owned vehicle or electric vehicles are parked. In a 24-hour day, almost 23 hour, our vehicles remain parked. So there is enough opportunity to us to transfer our energy of the vehicle to the grid as and when required. And during off-peak hour, we can charge the battery. So vehicle to grid concept is gaining importance day by day. So these are some of the information. Average personal vehicle is on the road only 4 to 5% of the day. and 90% of personal vehicles are parked even during the peak traffic hours. So this V2G configuration could provide additional revenue to the owners who wish to sell power back to the grid and profit from the use of electric vehicles, because electricity is cheaper than the petrol. So these are some of the important reason behind the importance of the vehicle to grid concept increasing day by day. This is also easily understandable diagram. So vehicle to home and home to vehicle. So if your home is powered with the solar PV panel, then vehicle can be charged independent of the grid power, and the excess power of the vehicle can be transmitted to the your household for lighting purpose or other electrical appliance use purpose, utilization purpose. And when required, you can take power from the PV panel or from the home to charge the battery. And also intelligent chargers are there. So intelligent chargers actually aware the vehicle owner about the dynamic pricing system of the electric utility, and accordingly you can charge your electric vehicle traction battery, and when your vehicle remain idle, you can sell the power to the grid. So vehicle to grid concept and grid to vehicle concept, vehicle to home and home to vehicle. So all these things are possible. And intelligent chargers protects overcharging, discharging of the traction battery. So this is the daily load curve. So in daily load curve, we observe different peaks are taking place, and these peaks are not desirable for power system economic operation point of view. So peak should not be there, but peak is there. So we can try to levelize this peak as much as possible. So electric vehicle can be uh, integrated in our system in this fashion during evening time when the peak demand is more. During that time, the electric vehicle can be released, and it can fulfill the additional demand of the grid. So grid demand will be less. And during off peak hour, during daytime, when the demand is less, electric demand is less, electricity demand is less, during that time the vehicle can be charged. So in this way, peak load curve can be flattened, which is a important thing for energy management point of view also. So this is the extension of that diagram. Load leveling is possible during off-peak hour, grid to vehicle, during peak load hour, vehicle to grid, and again off-peak hour, grid to vehicle. So in this fashion, we can integrate our electric vehicle into electric utility system. Advantages of the vehicle to grid to utilities. Some of the advantages are not only by supplying electricity to new vehicles, but by drawing power from them to maintain ancillary services, fuel the nation's vehicles at only the marginal cost of fuel, provide valuable generation capacity at peak times, reduce emission and air pollution in the electricity sector. So these are some significant benefits from this vehicle to grid concept. This diagram is taken from the International Energy Agency. So it is found from this diagram is that the oil share in primary energy resource is declining day by day. The main reason is that the oil reserves are diminishing, and another reason is the electric vehicles penetration in the market. So in coming days, this share of the oil in primary energy resource will become less more. Regarding Indian pollution, some of the important informations are like that India is one of the world's largest importers of the fossil fuels, and India spends huge amount of money for importing the fossil fuels, particularly the crude oil. India has the world's worst air quality according to the 2020 to 2020 World Air Quality Report. 22 Indian cities are among the 30 most polluted cities in the world, with transportation being the primary source. Even during the COVID crisis, with national and state lockdowns, 36 cities out of 50 cities which had unhealthy levels of air quality were from India. The average rate of new vehicle registration in India is 17%, and negative impacts on health, such as a tenfold increase in air and noise pollution due to this IC engine. And nearly two-thirds of the death in India can be attributed to emissions emitting from the IC engine vehicles. So this is the some of the concerning issues from the transport sector in Indian subcontinent. Also, the transport sector accounts for 18% of the total energy consumption in India. This translates to an estimated 94 billion tons of oil equivalent energy. And if India were to follow the current trends of energy consumption, it would require an estimated 200 million tons of oil equivalent of energy supply annually by the year 2030 to meet the demand of this sector. At the moment, this demand is being met mostly through imported crude oil, which therefore makes this sector vulnerable to the volatile international crude oil prices. Also, this sector contributes an estimated 142 million tons of carbon dioxide emissions annually, out of which 123 millions transport segment alone. We have all know about the COP21 summit. COP means Conference of Parties 21 summit. So number of conference of parties summits had taken place since last many years. So this summit was held in Paris, and it was a very important for to tackle the climate change issue. And to tackle the climate change issue, it was decided to reduce the greenhouse gas emission, to reduce the global warming level, and it was decided to reduce our global average mean temperature below 2 degrees centigrade, well below 2 degrees centigrade, preferably 1.5 degree centigrade in comparison to pre-industrial level. But in Paris summit, COP21 summit, pre-industrial level was not defined. So there are different thoughts about the pre-industrial level. So it is assumed that 19th century is the pre-industrial level, and some opines that the late 19th century is the pre-industrial level. Pre-industrial level 19th century means which starts from 1800 to 1899, that is 1900. So from that level, 2 degrees centigrade temperature of the globe is to be reduced. And in view of the climate change, the commitments made by the government of India during that summit held at Paris to reduce emission intensity by 33 to 35% by 2030 from 2005 levels. And to address these issues, the Central Ministry announced a goal to transition from new sale of IC engine, that is petrol diesel vehicle, to 100% plug-in electric vehicle by 2030. So this is a major reason behind the first promotion of the electric vehicle in India, due to the commitment of Government of India in that summit. And presently, electric vehicle scenario in India is not so much promising. It means that number of vehicles on road, electric vehicle is very less, around 1% is electric vehicle across the country. And some statistics I have mentioned, with the roughly 69,500 electric vehicle comprising only 0.085% of the 80 million registered vehicle, the potential for growth in India is immense. So this statistics is 2-3 years old. I think meanwhile the picture is little bit improved, but till it is a fact that a number of electric vehicles are far less in comparison to our conventional IC engine vehicle. And India government has taken number of policy. Bureau of Energy Efficiency is the nodal agency for roll out the charging infrastructure in the country. Besides, mission on transformative mobility and battery storage is there. In this program, it aims to support establishment of large scale export quality battery and cell manufacturing gigafactories in India with a total of 50 gigawatt hours capacity. and also Ministry of Road, Transport and Highways, MORTH, uh, suggests that sale of electric vehicle without the pre-fitted battery, because the battery is the major component behind the cost of the electric vehicle. And the main argument for this policy incentive is to delink the cost of the battery and the vehicle, as battery can account for almost 40% of the electric vehicle costs. The some of the policies I have classified over here. This is the National Electric Mobility Mission Plan 2020, and it was initiated in 2012. And thereafter, this electric mobility mission is further extended through FAME and FAME 2. FAME means first accelerated uh, first adoption of the electric vehicle and hybrid electric vehicle, which started in 1st April 2015 and last 31st March 2019. That is 15-19 fiscal, the FAME scheme was there. Thereafter, FAME 2 started since April 2019. Besides this FAME 1 and FAME 2, state government electric vehicle promotion policies are there. Extended PLI scheme is there. Vehicle scrappage policies are there. So some of the highlights of these policies are like that. In 2012, the National Electric Mobility Mission Plan, that is NEMMP 2020, was published. And under that plan, the first phase of FAME, faster adoption and manufacturing of electric and hybrid vehicles in India, and it was implemented during 15-19 financial year. Thereafter, this FAME 2 has come up, and a number of incentives are given. The GST on the purchase of the battery electric vehicle is also lowered from the 12% to 5%, with the goal of having electric vehicle share 30% of the total vehicle by 2030. Electric and hybrid technologies, including the mild hybrid, strong hybrid, plug-in hybrid, and battery electric vehicles, are covered under this policy. Also, this policy supports about 2,700 charging stations in the largest cities, other cities with over a million in population, smart cities, and cities in hill states across the country, with the objective of having at least one charging station in every 3 square kilometer grid area. In addition, charging stations are planned for every 25 kilometer on highways. Apart from that, almost 50% of the Indian states have their own electric vehicle policy, or in the process of finalizing the electric vehicle policy. And these state policies overall aim is to promote India's transition from IC engine to electric vehicles. The objectives of each state level policy will vary, but some common objectives that these policies include is to solve air quality issues, help in climate change mitigation, reduce dependence on oil imports, and promote development of electric vehicle industry. Almost all of the state policies prioritize 2 and 3 wheelers, public transportation, and job creation. This is another scheme and known as the production linked incentives, which provides supply side incentive to domestic manufacturers. Foreign companies are invited to set up factories in India, and local companies are encouraged to set up or expand existing factories. And in the major push for electric vehicle, this production linked incentive scheme for advanced chemistry cell battery manufacturing is also promoted, since battery cost can comprise up to 50% of the cost of the total vehicle. So improved battery chemistry has the potential to reduce the price while using cutting edge and safer technology. Another important policy of Government of India is the vehicle scrap policy. It aims to reduce India's oil imports through greater deployment of new fuel efficient vehicle to reduce environmental and noise pollution, to improve road and vehicular safety by removing old, unsafe and unreliable vehicles. And provisions are broadly arranged into 3 groups, mainly registration and fitness test, financial incentives, and scrapping centers. So if we summarize, so these are the policy schemes of the Government of India in recent past or recently. Union government policies like schemes FAME 1, FAME 2, PLI schemes, and the scrappage policy to encourage the use of electric vehicle. About 50% of Indian states have their own policy for promoting of the electric vehicle. Concessions to users, including a financial subsidy on purchase, exemption from road tax, registration charges, and low interest rates on loan. Electric vehicle owners can claim income tax deduction up to rupees 1,50,000 under Section 80 EEB. Incentive for bulk purchase of electric vehicle for the public sector, personnel, and public transport entities. Infrastructure development for battery and vehicle manufacturing, charging infrastructure, and scrapping centers. Some of the benefits of the electric vehicle, these are already mentioned, but anyway, these are mentioned here more specifically. Some economical benefits are there, like every electric vehicles have fewer moving parts as compared to the IC engine vehicle. So electric vehicle need less maintenance, higher efficiency, lower fuel cost, lower operational cost, makes electric vehicles economical than IC engine vehicle. Also, air quality is improved. Electric vehicles have no tailpipe emission as compared to IC engine vehicle, and it will help in reducing local air pollution and reduce greenhouse gas emissions. Lot of conveniences are there. Electric vehicles have no gears and are much easier to drive than IC engine vehicles. The lack of combustion and mechanical drivetrain makes electric vehicles much quicker. Comfortably charge at home. Upfront incentives from government to electric vehicle owners, incentive for scrapping IC engine vehicles. Electric vehicle owners can claim income tax deduction up to rupees 1,50,000 under Section 80 EEB, reduced dependence of imported fossil fuels for the country. Charger is also very important thing. So both fast and slow moderate chargers are available. For 30 kilowatt hour battery pack takes less than 1 hour to be charged up to 80% using the fast charger, and using the slow moderate charger, that is the 15 ampere plug, it takes around 8 hours. There are some questions, frequently asked questions. What is the cost for charging the electric vehicle? So this formula can be utilized. The cost to charge the electric vehicle can be calculated by this formula: battery capacity in kilowatt hour into electric vehicle charging tariff in rupees per kilowatt hour, referred to state EV tariffs. Different states have their own EV tariff. So if battery capacity is multiplied with that one, then you can find the cost of the charging the battery. So one illustration is mentioned for one Tata Tiger and Tata Tiger EV. Tata Tiger has two models. One is the normal IC engine, another is the electric vehicle, has been considered for this calculation. Tata Tiger has acclaimed range of approximately 20 kilometer per liter. So mileage is 20 kilometer per liter. Assuming a running of 100 kilometers, it would consume around 5 liters of petrol. So 100 divided by 20, so 5 liter of petrol is required to run 100 kilometers with mileage of 20 kilometer per liter by Tata Tiger. And assuming petrol cost 86.95, then the cost for 100 kilometer traveling is coming around 434.75. So we can assume around 500 for 100 kilometer running. If we consider the Tata Tiger electric vehicle, the total battery capacity of the vehicle is 21.5 kilowatt hour, and the total cost of charging that electric vehicle would be 21.5 kilowatt hour, that is the capacity of the battery, and it can be multiplied rupees 4.5 per kilowatt hour. Here we have assuming the charging tariff for the Delhi, so respective state tariff can also be used. So it is coming around 96.75. So this Tata Tiger can travel 140 kilometer with full charge. So you can travel 142 kilometer with 96.75 with electric vehicle. But for traveling 100 kilometer, you require almost 500 rupees by normal IC engine vehicle. So it is much more economical. Where can I charge my electric vehicle? Electric vehicle can be charged either in the public charging stations or at your home. Government is deploying PCS, that is the public charging stations, at a faster pace so that electric vehicle owners can charge their vehicles comfortably. Apart from this, many oil marketing companies are setting up electric vehicle charging stations at their oil retail outlets, fuel pumps, such that electric vehicle owners can easily locate charging stations. Whether electric vehicles are safe or not, it is also a question. All electric vehicles batteries go through rigorous testing procedure at National Accreditation Board of Testing, that is NABL, National Accreditation Board for Testing and Calibration Laboratories, certified labs. And and benefits are there from the government for purchase of the electric vehicle. As I have already mentioned, different tax reliefs, incentives are there. EVs take too long to charge. It is also a myth. Currently available electric vehicles across vehicle segment, two-wheeler, three-wheeler, four-wheeler, can be charged from 0% to 80% in around 1 to 5 hours using slow or moderate chargers. While using fast chargers, electric vehicle can be charged in less than 1 hour. Fast chargers are mainly used to charge the electric four-wheeler. Also, if we have low range, it is also a contention. So the average range of electric two-wheelers currently available in the market is around 84 km per charge. And the average range of electric cars available in the market is between 150 to 200 km per charge. And also electric vehicles offer better acceleration and speed. These are some of the challenges for promotion of the electric vehicle. Availability of adequate charging infrastructure is one of the key requirements for accelerating the adoption of electric vehicle in India. Also, developing charging infrastructure faces a lot of barriers. In some cases, high land rent prices, lack of available land on which charging infrastructure can be installed, high cost of commercial electricity and stability of the grid in many areas of the state. The transition to electric vehicle at local or city level also has several challenges such as coordination between departments, synchronization of action, geographical planning, and financial constraints. And the quality of city roads will also play a critical role, as the roads will need to be upgraded due to electric vehicles being heavier than the IC engine vehicles, largely due to the battery. And under ordinary circumstances, most Indian cities have poor quality road conditions, and they are mostly likely to get worse during monsoon. And research suggests that having better and good quality roads, in fact, reduces greenhouse gas emissions as well as improves electric vehicle travel range. These are some popular electric cars in India: Tata Nexon electric vehicle, MG ZS EV, Tata Tiger EV, Hyundai Kona electric, Mahindra E20 Plus, Mahindra E Vertio, Tata Tiago EV, Mahindra E KVU 100, Nissan Leaf, Mahindra XUV 300 electric vehicle. So their battery capacity, distance per charge, recharge time, price. So these things are summarized to get some information. And Government of India announced the Deen Dayal scheme in June 2014, which would help in the financing and procurement of the battery rickshaws in the country. E-rickshaw is also there. E-rickshaw is also gaining popularity across the country. And I belong to state Tripura. In January 2014, Tripura became the first state in India to regulate the functioning of the e-rickshaws. And they came up with the Tripura Battery Operated Rickshaw Rule 2014 for the purpose. Tripura has also its electric vehicle policy, which has been published a few months back. And some recommendations are summarized over here for electric vehicles promotion purpose. Adequate capacity addition primarily through renewables in distribution grid in order to meet additional demand created by high penetration of electric vehicles. Electric vehicle charging station to be designed preferably with rooftop solar generation. encourage EV manufacturers to design vehicles with changeable batteries, use of dynamic pricing model and smart grid tools for charging stations, intelligent charging stations equipped with fast chargers, timers, and capable of switching to normal charging mode, battery disposable recycling norms, investment in R&D for future battery technologies, use of information technology to locate the charging stations, and future of the hybrid electric vehicle. As you can understand, the petrol or gasoline will be more expensive day by day, and it is presumed that 2037 is the gasoline run out year, and around 400 millions IC engine vehicles will be scrapped and it will become useless car in coming days. And by 2040, it is anticipated that 90% of the world's vehicle will be the electric vehicle. So as the fossil fuel reserves are going down, so there are no other alternative to think about the different option. So we have to uh, support the government policies to first implementation of the electric vehicle in the country, particularly in the emission point of view and environment point of view, uh, global warming. So all these issues can be addressed considerably by execution of the electric vehicles in our country. So these are some of the information I have shared with you. Some of the informations I could not update due to paucity of my time. I beg to be excused. But I am very much thankful to Tamil Nadu State Center for giving me time to interact and to share something. And I would be very happy if these informations are found helpful or thought-provoking to the young generation, to the students. So thank you so much, Chairman, Honorary Secretary, other state committee members, distinguished corporate members, and participants for your patience hearing. Thank you.
Thank you so much, sir. I think it's a eye-opener session. So I'm Gokul, our honor secretary. If I think it's a big crowd, I think almost 75 people have joined, and now 62 is there. If anybody is having any queries, I think they can unmute and they can ask. Mr. Pon Ilamalai from Canada, I think good. So people are watching from Canada also. So thank you, Pon Ilamalai, sir. So you can put your, you can unmute and you can ask your questions.
Yeah.
Gokul, very good
Thank you.
evening.
Thank you very much. I am from Canada, but I am a native of Chennai only. Okay. Sir, Mr. Subhadeep, I really thank you profusely for your erudite lecture. Turned in this 1 hour. It is both an interesting one for the beginners as well as the experts. You have packed the session in such a way that it is quite illuminating by 360 degrees. That is what I can say. Thank you for that. Just I want to say certain things for your consideration, because I do whether these facts remains to be reviewed. I am an energy auditor by profession. That is why I am into that. You said the incomplete combustion is only the result for emissions. That's not so. You please look into this. Incomplete combustion will increase the emission, but even complete combustion will have its emissions. That is one factual error. Secondly, in your slides, I consider the transmission loss is around 6% and the distribution loss is around 8%. Please look into that. And thirdly, you said the IC's consumption is around 18% of the oil usage. But when it is shifted to electric vehicles, definitely it will lead to the consumption of more units, as well as the maximum demand of the grid has to go to that extent. This is a more significant portion. And the transmission lines are also to be strengthened. I don't think that the government of India is taking action in this direction. They are only investing on renewable energy. That's good, no doubt, that's good. But unless otherwise the load centers are properly designed, the transmission lines will become a bottleneck in this approach. Third, you said EVs have no gear. But you say EVs are also matching the speed of the IC engine or even better than the IC engines. That is conflict, I want to know. And lastly, only 5% of the vehicles are on the road, even during peak hours. This statistics is a surprise for me. I want to confirm whether it is right. Thank you, sir.
Okay, sir. Maybe that emission related issue I will take care of because I am not an automobile engineer. So whatever I have information gathered, neither I am an electric vehicle expert also. So whatever information, general informations are available, I have shared. And much of the information I have taken from the Bureau of Energy Efficiency website. So under the Ministry of Power. And regarding that transmission losses, so it is related, not related to our country, maybe particularly because in our country, the transmission and distribution losses, which is actually known as the ATNC loss, aggregated technical and commercial loss, it is average 25%. Okay, and the transmission loss, distribution loss is more than the transmission loss. I belong to northeastern region, so ATNC loss is around 50%. Okay, so you are right, the transmission is to be strengthened, but it is some indicative, it is some suggestive. Some developed nations, the TND losses are below 10%, 5%, 6%, like that. And another one you have told, electric vehicle, I think related to this statistics.
MT management. The anticipated maximum demand, what is the planning of the government to meet it?
Sir, where it is mentioned.
Yes, no problem, sir. I think we will
Okay,
leave.
okay, sir, I will take care of it. Just you also note down my email ID. Email
Yes, sir.
ID is there. You kindly please note down the email ID. And if any other queries are there, you please write it to me. I will try to clarify.
Bhattacharjee at yahoo.co.in.
Yahoo.co.in.
Sir, I
Thank
have
you.
one question, sir. I have a question, sir.
Yes, sir. Just please give your introduction, sir. Then you can give the question, sir. Bhaskar, sir. Yeah.
Sir, thank you very much, sir.
Thank you, sir.
Hello.
Thank you. Yes, yes.
Sir, I have one question, sir. Only one question. Sir, the conventional vehicle, this electrical vehicle is costly, sir. What is your observation? See, normal vehicle is very less when compared to electrical. Why this much hike, sir, electrical vehicle? Can you
Sir,
answer?
answer that what I have also observed, it is because of the battery, because that is why the government is thinking about the delinking the battery. Okay, so battery is the almost 40 to 50% of the cost of the electric vehicle. So if the vehicle is sold separately and battery is sold separately, then the price will come down. That may be one of the potential reasons.
Okay, sir. Thank you, sir. Thank you, sir.
Yes, sir.
Sir, very good evening, sir. Am I audible to you all, sir? Please.
Yes,
Yes.
madam. Yes, sir.
Sir,
can
this
just
is
give-
Maheshwari, committee member for TNSC. Right now, I am speaking from US. Very good evening to one and all. The speaker has given information very elaborately, right from starting from the conventional and various different types of e-vehicles and the working and the various policies which has been extended by our government and everything. And I think it will be a very useful session for all, including the teaching members and the student community also. And in this regard, I thank wholeheartedly the resource person. And I'd like to give two questions on this line now. One question is, what is the cost variation when compared to the electric vehicle and the conventional vehicle? And another thing is, in his presentation, he has mentioned the cost is only because of the battery, which is around 40 to 50% of the cost. But recently, which I've read from the newspapers, the lithium, it has been identified from our north part of our India, which will be very useful for the fabrication of the battery, which will not, I just want to know whether this introduction of lithium for batteries, whether it will be reducing the cost of the electric vehicle. I would like to the resource person to throw a few lines on these aspects. Thank you, sir. Thank you for the opportunity.
Okay, madam. Regarding this battery issue, I am not so much aware of it. But the thing is that the battery, you know, is the most expensive one, not only for the electric vehicle, even for the standalone PV system also has not become popular due to this battery backup. That is why the grid connected system is promoted. So it is reason. And one illustration I have mentioned regarding the economics of the electric vehicle versus IC engine vehicle, which is also given by the Bureau of Energy Efficiency, Ministry of Power, which are one of the nodal agency for promotion of the electric vehicle. So I think you will get some of the answer from this illustration, that is regarding this battery capacity and the mileage of the. I think, madam, have you got your answer from this illustration?
Yes, sir. Yes, sir. I'll look into it, sir.
Just,
No, I
just,
think I just want to know whether the introduction of lithium, which has played a role or not. That's all, sir. Thank you. Thank you.
That is not, I am not so much aware of it, madam.
Yeah, thank you, sir. Thank you, sir. We'll look into
Okay.
this. Thank
Okay,
you.
okay.
Sir, can you share your cell number, sir? We'll
Yes,
have
yes,
a
yes,
question
yes,
forward, sir.
yes,
Yes,
yes. My WhatsApp number is also there. So 9436582874. And also it is available with the chairman, Tamil Nadu State Center.
Sir,
Yeah,
can you
I
please
can share
repeat
it.
it?
I can share your email ID and phone number, sir. Yeah.
Okay, okay. 9436582874.
Radhi, you can share the Tripura State Center chairman numbers, mobile number and email ID to our group.
Thank you,
Okay,
sir.
sir.
Okay,
Okay, sir.
okay, okay.
Sir, thank you very much, sir. This is a very
Thank you,
excellent
thank
lecture.
you. Thank you,
And
thank you.
you prepared,
Just I
you
want to
took a
add.
more effort for preparing the slides and giving the PPT. And most of the
As-
members are very curious to ask questions also, given the nice answers. And thank you
Sir,
very much. Thank you very much,
1
sir.
minute.
Thank
I would
you.
like to add an information for the question asked by Madam Maheshwari. To my knowledge, the cost of the battery is not coming down, but to its lifetime, it is given the warranty for more than 10 years life of the vehicle. Lifetime, it is given more, and that is an attractive proposition. And the running cost is also less. So by both these facts, definitely, though the cost is higher, it is more attractive still and cheap. Thank you.
Sir, you are speaking from Canada?
Yes, sir.
Yeah, thank you very much for every online lecture you are coming and supporting us. And thank you very much for your curiosity. Yeah.
I am the regular visitor of Institution of Engineer. I am a member of that. And I have been, whenever I was there in Chennai, I never failed to visit IE lectures.
Oh, thank you. I think I should have opportunity to meet you in person in Chennai.
Yeah.
Maybe you will please
your-
inform us when you are coming here.
Your past chairman, Dr. Tirunagwarsi, is my best friend.
Okay, thank you.
Sir,
We
one
are also your
information.
best friends, sir. Thank
Sir,
you very much. Go please
sir,
then.
Sir,
Yeah,
just one information I have received recently from some WhatsApp text. That is, I'm not sure. It is a message that Norway now their number of electric vehicle is more than the IC engine vehicle, and they have declared earlier that 2025 onwards they will sell only zero emission vehicle. So I think Norway has made some record. They are the first for getting this success, and the vehicles on road is more than 50% is electric vehicle in comparison to China and other nations. I think sir from Canada can also verify this fact.
Yeah, it is true. It is
Okay.
true. I will add one more information for that. The message is true, but the position is in Norway, they use less vehicles, cars. They use two-wheelers, cycles. That is also there. So in that way, they are forerunners in that, but the vehicles are very less there. It's not so dense as in Canada or North America.
So thank you very much for our council member, committee members, and fellow engineers, and our faculty from Tyagarajar Polytechnic for attending this program, wonderful program. And once again, thanks to Dr. Bhattacharjee, the State Center Chairman, Tripura State Center. And thank you very much, sir. And now we can go for vote of thanks by our Honorary Secretary, Engineer Gobul. Yeah, please.
Yes, sir. So very good evening to all present here. So always I think IEI Tamil Nadu State Center is organizing the online webinar. So it always boosts by connecting the complete global level of our Tamil Nadu State Center members. So one among we can see Elumalai sir, who is always been there for all the lectures. So with this, I should special thank goes to our the chief guest today, our Subhadeep Bhattacharjee sir. Definitely, I think even though like I think he has delivered a lecture on EV, which is on the principle as well as how the technology is moving up on the policy level. Definitely, it makes many people to know about, because people think EV is something like electric vehicle which has the batteries and other power system. But there are so many subsystems also involved, and how the policy level the government is also taking up. With this, thank you so much, sir, for joining from our Tripura. Definitely, I think we are in the almost southern part of our country, and you are in the northeast part of the country. So it's all always we connect each other, and we make our IEA much more stronger. So thank you so much, sir, for joining us this evening of Saturday. So definitely, even though you have a busy schedule, you accepted to deliver this online lecture, and you made our people wonderful. Thank you so much, sir. I also extend my thanks to our chairman, who is always a bound leader, and who's always creating a lot of networking for, especially for our growth of our Tamil Nadu State Center. So that's what, sir, whenever he goes for council member meetings or is networking people, definitely he will bring one person for our Tamil Nadu State Center for delivering and transforming the knowledge. So this also happened today. So thank you so much, sir, for bringing the wonderful speaker and made our all the members more enlightened. So I should extend my thanks to all the corporate members of our Tamil Nadu State Center, also IEA members across India, and also all the executive members of our IEA Tamil Nadu State Center. So without the executive member, we always cannot push any of the events. So their complete support is always for us. So I also thanks to all the faculty and the student member of the Tyagaraja Polytechnic College, as well as other student members of all the student chapters of India. So last but not least, I thank all our staff members, Agartala madam, as well as our Lalita madam, who supports from our office for all the online as well as the connecting media. So if I would have missed anyone, so I thank all the people for joining this event. And we have a next event which we planned it in offline. So we have the seminar, All India seminar, which is planned on Environment Board. Since our chairman is also Environment Board chairman, so next October 5th and 6th at Chennai Anna University, we are planning it. So I request again all the corporate members and the executive members and student members to join for the seminar and get a lot of enlightening knowledge on the environment. Thank you so much. Thank you, sir.
Thank you, sir.